Okay, so hello everyone. Welcome to my talk, Taste the Difference with Scala 3, Migrating the Ecosystem and More. My name is Jamie Thompson. I'm a software engineer at Scala Center, and I work on Scala 2 and 3 compilers. And I'm available on GitHub and Twitter at Bishabosha. So in today's talk, well, we're celebrating that Scala 3 is finally launched. So we'll be taking a little look at why you might want to upgrade to that, and also the process of how you actually do this migration from Scala 2.13 to Scala 3. And finally, we'll take a look at some of the things that we've changed to make sure that we maintain compatibility between Scala 2 and 3 going forwards. So why do we want to use Scala 3? I picked some examples that I'm going to show you. But for me, mostly, I think over Scala 2, it's more simplified, and we bring more power, and there's improvements to safety of the language. So one simplification that I think is very nice is that it's very simple and concise to declare new data structures with the enum construct. As we see here, we're declaring color in 2 lines and an alternative for the option data type in 3 lines. Very compact. Another simplification that we might want to take advantage of is that we have top-level definitions. There is no longer any need to invent a name for some imaginary package object. You can just write a method at top level. And as a bonus here, if you use the annotation at main on the method, it turns into a program that you can compile in 1 line in the command line, for example. Scala hello.scala will then compile and print hello ScalaCon. Another simplification that I think is very useful is extension methods. We simply declare with extension keyword and then an argument, and then we can define some methods. For example, here we define method twice, which concatenates a string to itself. As an example, we see the string a.twice is equal to the string AA. One of my favorite things that we added in Scala 3, which I put in the category of powerful additions, is match types, which can be used for metaprogramming, for example, to have compile time constraints about the types in your program. Here we implement the GCD function using just types and compile time operations that are a new addition to the Scala 3 library, which you can import from the Scala compile time package. And we import it here, and basically it's just a pattern match. And the result is that we summon a proof that GCD of 252 and 105 is 21. Sorry about that. So you can find many more changes to Scala 3 on the documentation website, which is docs.scala-lang.org. And I've highlighted, if you scroll down, there's a section called New in Scala 3. And if you click on that, you can see an overview of all the new features in Scala 3. So what does Scala 3 mean for migration of our projects from Scala 2? Well, we're taking a new step this time because for the first time in a Scala compiler release, we actually have forwards compatibility and backwards compatibility. So if you are compiling your code with Scala 3 of some minor version, some patch version, you can depend on a library that was compiled with Scala 2.13, and that should work just fine. Similarly, if you are compiling with Scala 2.13, you can depend on a library from Scala 3, and it should also compile just fine. This is for the first time ever, really, because, for example, before 2.13 was not backwards compatible with 2.12, and 2.12 was not forwards compatible with 2.13. So we have this goal that, say you are just migrating your project from Scala 2.13, and either you're a library maintainer or you just have an application and you depend on some libraries. The best goal possible would be to immediately switch to the Scala 3 compiler by just changing the Scala version number, or to change a library dependency to a Scala 3 version if they published a new version, and we want the build to keep succeeding. What this basically looks like is that, say we have a graph of projects that depend on each other. These are all compiled with Scala 2.13 and they're colored red. And then the white just means there's a dependency. So we want to say that at some point, anywhere in this graph, one project can change to Scala 3 and then depend on maybe some Scala 2 libraries, and some downstream libraries can then maybe depend on its Scala 3 version. And then slowly but surely, we translate all the projects over to Scala 3. So we want to have this sort of freedom for anyone to mix and match between the two compiler versions. So how can you actually do that? It seems quite magical, shall we say, but it's possible. So what you want to do is that when you first take your project, the first thing you need to do is basically change the build, and that basically involves changing Scala version or some dependencies, and then we see if it still compiles. And if it compiles, then great, you're done. If it does not, we might need to make some changes to the code. So how do we migrate the build? Let's say that if you were, well, actually first, all you need to do is if you use SBT, if you use SBT version 1.5 or greater, then Scala 3 is supported out of the box. There's no need to use this SBT Dotty plugin anymore. You can delete it from your build. So let's say you are in a Scala 2 project and you are now wanting to depend on some Scala 3 library because they've added a new feature and they stopped building for Scala 2, let's say. So you can see in this build, I'm using Scala 2.13.6, and we have to add a new Scala C option, which is an argument to the compiler, which is -y tasty-reader. And what this enables us to do is to read the Scala 3 dependencies. But to actually add a Scala 3 dependency to a project, all we need to do is take the module ID and wrap it with a cross-version extension method, which basically lets us use the Scala 3 version of the library when the compiler is Scala 2. So the syntax you need is .cross, and then pass the argument cross-version dot for 2_13, use 3. With the opposite scenario, let's say you have updated your module from Scala 2.13 to Scala 3.0.0. So we can do that now, that's quite fun. Essentially, let's say that you've just done this, but none of your dependencies have updated yet. And normally, if they haven't published yet for Scala 3, then you're stuck, you can't use them. That's not the case this time. Essentially, all you have to do is add a Scala compiler option to say that you're migrating your source code using the option source 3.0 migration, and what that does is reuse some Scala 2 language constructs that are removed in Scala 3. So it basically allows you to use the old keywords that are now forbidden, but in Scala 3. And then in order to use the Scala 2.13 version of a dependency, similarly use this cross-version syntax, but instead you say for 3 use 2.13. So yes, to recap, this is you take a library, you change the Scala version to 3, and then your dependencies are not yet published for Scala 3, so you use the 2.13 version instead, using this cross-version syntax. So let's take a look at, for example, if you did migrate the build, you changed the Scala version, but now it doesn't compile. There's something that has changed in your code that is no longer supported in Scala 3. So what could some of these be? Some examples that are no longer supported, but have sort of an automatic rewrite available to migrate you from the old syntax to new syntax is, for example, if you use a do while loop, you now need to change it into a while do loop. Similarly, for procedure syntax or auto application, or the removal of symbol literals, and then sometimes eta expansion. Sometimes you can just get away with this without doing any migration by using, again, the compiler option source 3.0 migration. This basically enables that old syntax, but if you don't have that option, then you'll get an error. Some other features that are dropped, but there are no automatic fixes or patches, are that you can't use Scala 2 macros, you can't call a Scala 2 macro, you can't use existential type syntax, and you can't call a library that uses existential types from Scala 2. And for example, there's some other things like abstract type projection that is no longer supported. So if you use these in your source code, you'll get a hard error, and you need to rewrite them in some other way, which will show you how to do that in a moment. Then there are some things that aren't hard errors, but might be a slight change between Scala 2 and Scala 3. So if you left out the result type of some public API, then maybe it will be inferred to have a different type between Scala 2 and Scala 3. This is quite rare, but there are some occasions where type inference gives you a different result. Also, some new rules for overload resolution and implicit resolution, which might make some ambiguities. But these are, again, turned off when you use that source 3.0 migration mode. So that's a good one to remember. I've also put import foo.star here because previously that meant import the term or method or field called star from foo, but now it means import everything from foo. So you can get some confusion there. But, and then finally, yes, so there's some changes to code that's automatically generated, for example, getters and setters with the bean property annotation. And also you must now put a return type for any implicits if you didn't have them before. And also case class companions are no longer extending function traits, and the unapply signature has changed, which we'll cover very shortly. So essentially, all these changes are all covered, again, on the Scala documentation website by going to docs.scala-lang.org, scroll down, and you see a migration guide, which has been produced by my colleagues at Scala Center, and it basically is a database of everything that we know that doesn't work between Scala 2 and Scala 3, and gives you advice on how to migrate those things. Let's take a look at one kind of interesting example of source code incompatibility that you would need to change, which is the unapply method on a case class companion object. So yeah, so let's say we declared a case class location, and we create a value Lausanne, which is the location where I am right now. So 46.5 degrees, 6.6 degrees. And we want to turn that location into a tuple. In Scala 2, what you could do is call the unapply method on the companion object of location and pass Lausanne, and then you get a sum of a pair of two doubles. And then you can call get, which then unwraps it into a tuple. And here we are extracting it into latitude and longitude. But when we try and compile this with Scala 3, we get an error. Why do we get an error? Basically, the return type of unapply on the companion object of location has changed. So now we can see that location unapply actually returns its argument. We see here that we assert that it is the exact same object that is returned. So Lausanne is not a pair anymore, it is now a location. So one way we can migrate this in a way that is cross-compatible with Scala 2 and Scala 3. So you could cross-compile this file is to first extract the arguments using a pattern binding and then construct a pair. It's a bit long-winded. And another way that if you just want to compile this with Scala 3 and you don't care about cross-compiling, then you can use this new API in the Scala 3 library on the tuple, Scala tuple companion object, which is called tuple.fromProductTyped. It can take any sort of case class and then automatically turn it into a tuple of the same number of fields as that case class. So yeah, we don't even need to infer anything. We just do tuple from product type with that, and we return a pair of doubles. So one of the more complicated migrations that we need to make in the code is that Scala 2 macros are no longer supported in Scala 3. So we can't call a Scala 2 macro from Scala 3. So we need to rewrite them in Scala 3 using Scala 3 APIs. So typically in Scala 2, let's say we make another location case class, but instead this one is the location of a line or a line and column in code. And we create a location with this macro. So we say def location of type location is a macro call to this location import method, which contains something that will generate a location. So in Scala 3, this won't compile. But what we can do, wait, sorry. This is the implementation of the location import method. So basically, it's a typical Scala 2 macro where we use some magic quasi-quotes to generate code. This will not compile in Scala 3. So in Scala 3, we add an additional method with the same API, but instead it's an inline method. Instead of being a macro method, it's now an inline method, which is one of the new syntaxes in Scala 3. And you might wonder, is this some sort of double definition? Because they're both called location, they both take no arguments, they both return location. Well, there's a special rule that says when it's a macro and there's a Scala 2 macro of the same name and type, then we basically shadow each other. And depending on which compiler is reading this API, it selects the one that it knows how to understand. So if Scala 2 was reading this API, it would pick the Scala 2 macro, and if Scala 3 was reading this API, it would pick the Scala 3 implementation. And here's the Scala 3 implementation of that macro using the new API. But this does not compile in Scala 2, so there's no cross-building here. So if we're putting these two definitions in the same file, this actually makes a problem for us because we can't cross-build this thing, and we cannot compile location implementation in Scala 3. So we need to keep it compiling with Scala 2. So let's say we had our project here. This is basically all the code that we saw just there. And it's in a project called location core. If we wanted to compile this with Scala 3, but not change the code, we now have to split out that macro implementation into another library that location core depends on, so that we can keep compiling that macro implementation with Scala 2. But there's another problem, which is that the macro depends on that location case class. So actually we have to now make another library that the location macros depends on, called location shared. So location shared contains the case class, and the location macros depends on that case class. And also the macro API front end depends on that case class as well. So this is a big, huge mess, but it would allow us to then compile that extra file that we saw before with Scala 3. But what we really want is to go from one step immediately to just compiling a location core with Scala 3. So how do we do that? Well, what we can do is, instead of having a separate library just to compile this one macro implementation, we can just port it to the Scala 3 so it can compile with Scala 3. Because Scala 3 can compile a macro implementation, it just can't use it. So this code here is just a rewrite of the previous code to avoid using quasi-quotes. And this will compile in Scala 3, which allows us to have just one library to contain all the macros. Yeah, so basically, now that I've shown you some ways to manually migrate, there is a lot that can be done automatically. And at Scala Center, we have developed a tool to help you do this. It's called Scala 3 Migrate, and it's an SBT plugin. You basically add it to your build, and it has a few commands to basically follow you through the steps that I explained earlier. So it will suggest how to update your dependencies if some exist for Scala 3. And it will also tell you which Scala options need to change if, for example, it is changed to be renamed, but means the same thing. And then it will also apply some syntactic rewrites and hopefully compile your code in as efficient way as possible. So I used this on a tiny little project just to demonstrate here, and it's basically applying some rewrites such as turning the while do while into a while do, and then finally it allows you to, says you've done it, you migrated, copy and paste this new Scala version to save it for later. So I recommend that you try this out. It's very useful and could save some headaches. So yeah, so that was basically how you can migrate your library, steps to take. And now I want to discuss how is this even possible that we're able to have this backwards and forwards compatibility between Scala 2 and Scala 3. So to answer this question, we have to basically look at what is a dependency? How are we able to depend on a library from Scala 3, from Scala 2? Typically, it hasn't been done before. And to answer that, let's take a look at this simple piece of code here, where apparently we're creating a value called cn, and it calls this thing like new DB, calls the method column names. And when the compiler sees this, it's asking some questions, like our goal for now is to say, what is the type of cn? And to answer that question, it looks at the right-hand side. And the first question it asks is, well, what is this DB? I haven't seen it before. Let's go and find it. And once it's found that, then we ask the question, what is column names? Is it a member of database class? Or is it some sort of extension method that we're adding from implicit scope? Or is DB actually dynamic and we're making a dynamic selection? There's so many questions to ask, and we don't know until we actually fill in the holes in our program by adding a dependency to our class path. So if we don't add a dependency to our class path, we just get the error, well, I couldn't find DB, so don't know what it is. And then we stop. So let's say we did add a library that contains a class called DB onto our class path. Just some random Scala 2.13 library that I made up. And now we have this, we can answer the questions. So we know now that database is a class, it's in the empty package, and it has a method column names in that class, and that method has the type of a method that returns a list of string. So now we know that we can answer our question, which is that cn has type list of string, and therefore we know that when we call map char at 0, we're going to get a list of char. Okay, so it's all well and good describing that process, but how does it actually work? So let's take a look at what happens typically in a Scala build. We have some code here, that database class that we just saw. And we have a build tool such as SBT that loads the Scala compiler, version 2.13 in this case, compiles it, and we get some classes and we bundle it up in a jar file. And that jar file basically has a little suffix that tells us that it was compiled by Scala 2.13. So Scala 2.13 has this thing called a binary version, which is 2.13. And that describes basically that it was compiled by Scala 2.13. Okay, so then step 2 is that we take that jar file and we also then look at that the app file where we were calling the database class. And we put the database jar file on the class path, and now we can pass that to Scala compiler, and it resolves those symbols in the database library to produce another jar file, which is like the app jar, which also has this binary suffix 2.13. Then the third step is that we take both those jar files and we put them on the class path of the JVM and run the program. So what's going on here? There's basically two stages where we have to resolve dependencies, which are when we are compiling the code and then when we are running the code. So basically, when we are compiling the code, when we add the database jar to our compiler class path, we're asking the question, can we discover any APIs in the database 2.13 jar? And if we do discover any APIs in that jar, then we can use them to compile the app. But then once we've produced the app jar, we then need the database jar again to actually call those methods at runtime. And at runtime, basically what we want to know is that do the calls in the app jar actually match the APIs that are available in the database jar? Because there's a translation to Java bytecode that is where the APIs are different from the source code. So we actually need to have basically two correspondences between APIs. At compile time, we need to know that the signatures in the library match the APIs that they were written with from the source code. And we need to know that at runtime that the bytecode corresponds, which means that the methods are available to be called as you expect them to be called. So what is signatures correspondence? Basically, again, let's take a look at this. So we have our database library, and it provides a method column names or list a string. But if we are depending on it and we only see the class files, then class files have gone through a process called type erasure, which means that when they were converted from Scala files to class files, we have lost some information. So essentially, the return type of column names has changed from list of string to a list of anything, a list of objects. So if all the information we had was just the class file, then when we try and call char at 0 on the elements of that list, we can't do that because char at is not a member of any ref. It's a member of string. So we need some sort of way to preserve the Scala types in that library dependency so that we can actually type check and call that method correctly. So that's what signatures are for. Is for the types of your program. Then when we have the bytecode correspondence, what that means is that, again, you have a library that defines a value class ref, which just wraps an object of type any ref, and has a method isNull that checks if the wrapped value is null. So when we depend on that library and we call the method isNull on a new ref of hello, we have to make sure that, well, essentially when we compile that dependency, we believe that this code here is the correct code stored in that library so that we can call it. So we have to make sure that the dependency that we're depending on actually provides us with those methods in the bytecode. So now we've seen that. That was all with the Scala 2 compiler. We now have a Scala 3 compiler available, and that's codenamed .c. And we see the Scala 3 compiler is a bit of a different shape to the Scala 2 compiler. And why is that? Well, it's because Scala 3 has been written from the ground up to be completely different. It has new internal representations of types and trees, and it has a different bytecode output even. So it really is like putting a cube and a cube and a cylinder together. They have sort of different shapes. So how do we make it so that when you try and swap the code that they're expecting, that they actually still work? So we are trying to get Scala 2 to read these foreign shapes of Scala 3 and Scala 2 to read the things it doesn't understand necessarily from Scala 3. So this is fine because we have basically built-in knowledge of the two compilers into each other so that we can have this bidirectional compatibility. So Dotty Scala 3 can depend on a 213 binary library, and Scala 2 can depend on a binary version 3 library. How is this possible? Well, we've built in support for the signature correspondence and the bytecode correspondence. And I'll show you how that works. So essentially, Scala 2, when it compiles a Scala source file, it does produce a class file. And that class file contains the Java bytecodes necessary to run the program within A. But it also stores an annotation which contains a list of all the APIs in that source code, but with Scala types. And we call that pickles. And basically, yes, so the Scala 3 compiler with the binary version 3 can read the binary version of a.class with 213 because it can understand those pickles and it knows how to translate that into Scala bytecode, Java bytecode, because we can read the pickles, but then we have a special mode for turning Scala 2 types into JVM bytecode. And the Scala 3 compiler, when it takes a.scala and compiles that, we get a.class, but we also get a second file, a.tasty, and we get the tasty file for any top-level class that is compiled. And basically, Scala 2.13 can read these tasty files and understand the signatures that are stored in there, the Scala types that are stored in the tasty file. And we also have, again, a Scala 3 erasure mode to understand some Scala 3 types and turn those into JVM bytecode. So what are these erasure modes? What is erasure? Erasure is what we call the stage in the Scala compiler where we convert Scala types into types that match what the JVM expects. And Scala 2 and Scala 3 have different ways of translating Scala types into bytecode. For example, in Scala 2, we have compound types, whereas in Scala 3, they're understood as intersection types. So that is basically where you have product with serializable, but Scala 3 has product and serializable, and these have different erasure modes. So basically, the methods in the bytecode will look different depending on if it was compiled by Scala 2 or Scala 3. And it's the same with the specialization of arrays, the element type within them. So basically, Scala 2 understands how to write Scala 3 bytecode, and Scala 3 understands how to write Scala 2 bytecode. And now I want to go over why we want to use tasty files and not just reuse pickles in Scala 3. So what is a tasty file? Essentially, it stores the whole program. So so it stores the whole program. So it has the signatures and the implementation. So pickles was just a list of APIs, but no implementation. So now we have the implementation as well. And tasty has a fixed meaning, and that means that essentially, it won't change. And once you read it, there is no more guesswork to be done by the compiler. So when you read a tasty file, all the implicit arguments are already filled in, all the return types are inferred, and we know which method we're calling at each point. There's no need to try and re-resolve which overload you're calling from a class. So why is this useful? Well, the reason tasty has the whole implementation is that we can actually recompile a tasty file back into the same class and tasty file. So it's an idempotent operation to keep compiling from tasty. Of course, we can also use the tasty file to read dependencies because a tasty file is stored in a library, so we can read all its APIs. We can also use tasty files to analyze code. For example, we generate documentation using the tasty file. And also the IntelliJ Scala plugin uses tasty to type all the definitions in your file. And yes, also tasty stores the implementations of macros, and when you make a splice or a quote, then that's stored in a tasty string. So we have built in this tasty reader into Scala 2 that can read tasty files produced by Scala 3 and discover the APIs in that Scala 3 library. But there are some, it's not quite one-to-one. For example, we do have full support for intersection types, enums, the new type lambdas, exported definitions, the new given instance syntax, contextual abstractions. You can read and use opaque type aliases with correct semantics. And also, you can call a Scala 2 macro that is stored in tasty. We have, though, a limited support for extension methods because you can't actually use them as an extension method. You have to basically call them in the prefix form, where you pass the arguments after the method name. And also, if you have a top-level definition, then you actually have to call it from its wrapper object. We would like to improve support for this in the future. And also, the following things are completely unsupported, and you get a compile time error if you try and read one of these from a library. So if there is a match type and you try and use it, you'll get an error. Same with generic tuples or union types, inline methods, trait parameters, context functions, etc. It's not quite clear how to support some of these, but some could be done. For example, generic tuples are just a simple erasure rule and typing rules. So to recap, let's say, so I showed you what I think Scala 3 means for me and why I think you should upgrade. And by showing you how we can upgrade, hopefully we can free the ecosystem. And I talked you through a little bit of how we are maintaining compatibility between Scala 2 and Scala 3. So that is the end of my talk for now.
Hey, Jamie, thanks so much for your talk.
Hello.
So let's check out the questions we have from Hopin. Looks like we have a couple. The first is, any examples of a migration that needs a particularly tricky rewrite?
Yes, I can definitely say that, for example, if you wanted to migrate, we had the M unit that migrated to do the that macro thing that I showed you. If we did the thing where you had to split up the libraries, that would have been totally impossible. So they had to port their macro in Scala 2 to Scala 3 to bundle it together. So usually when it has a macro, that's kind of the toughest thing to rewrite.
Great. So we have one more. I'd like to bring that up on the screen if that's all right. And okay, we don't have the second one up and ready, but for the remaining questions, would you mind going over to the Hopin stage Q&A area and giving us those replies in text, maybe even linking some important documentation for everyone?
Okay.
Amazing. Thanks so much.
Thank you.